So what I do, I just started the recorder. What I do every time I teach this class is I record the lecture and then I post it on YouTube. So if you don't come to lecture, you can still watch it. Okay. So usually I capture every single lecture, almost always, but occasionally I have a technical problem and I might lose a lecture in one quarter. But that's not generally a problem. So that's one thing. And just to move on, let's start by looking at this syllabus. And the prerequisite for the class, some exposure to programming. So if you've never done programming before, then you might want to think about slowing up and getting some programming experience first before you start the class. Now, if you're not sure how you think you'll do, you can talk to me after class, and I'll give you my opinion. You don't have to follow my opinion, but I'll give it to you if you want to know it. Okay. And so this is the lecture period. We have a lab. There's two labs, Lab A and Lab B. And this is the textbook. Now, I follow the textbook in terms of the sequence of materials. I present the same stuff as the textbook. I subtract a little bit from it. And, but I don't talk about the textbook specifically, but I cover the same material in the same sequence. So this is a good reference. But if you want to use a different textbook, because perhaps you already have another textbook that covers C++, you can probably use that because they're all very similar. You can present the material that we're covering in this class in different sequences. It's the same material. You can present it in different ways. So I'm presenting it in one way, the way that follows this textbook. But if you have another textbook that presents the material in a different way, that's still probably okay. And if you want to ask me about your specific textbook and what I think about it, and to identify the chapters that you need to look at, then bring me the book and I'll give you that feedback. Do you have a question?
Yeah. Do you mind, since you were just telling us that some of the material you're not going to cover, do you mind telling us what material you're not going to cover?
In the textbook?
Yeah.
You'll just have to notice it. Okay. Because it's a lot of little tiny details. So I cannot just sit here and list it out, right? Oh, maybe one thing in particular. In the textbook, it covers some graphics programming. And I think it's labeled as advanced or optional, something like that in the book. But we are not going to cover that. We're only going to cover programs that run in console mode. We're not going to we're not going to write programs that run in a graphical window. You see this is a graphical window right here. See that? And so you can write, this browser is a program. Right? A group of people wrote this program, a large group of people. It runs inside a graphical window. But here, well, I'll go through it this way. On the Mac, in any case, there's this terminal program. It's another program like the browser. And this gives what's called a console window or a terminal window. And all of the programs that we will write in this class will run as a console program. Will run in a terminal window like this. If you want to use an IDE like Visual Studio or Xcode, you can do that. And that is a graphical window. But the output of the program, the output will appear in a view within that IDE that is essentially a console interface like this. So in the old times, computers did not have graphical user interfaces. They didn't have mice right? That you couldn't point. You didn't have windows. You just had all you could see is this, and you would type in commands, and you would see the result. And the result would never be a line, wouldn't be a shape, would always be characters. And so we're using that old style interface because it's commonly used anyway. I mean, programmers use this old style interface all the time. It's very common. And it's something that perhaps most of you need to get used to. But it's not too bad. So that's one difference. In the book, they'll have example problems, example code that runs inside a graphical window like this, where you draw lines and circles. They have other programs that run in a console window like this that only output character data. And so these are the programs that we'll be looking at. So that part of the book you can chop out right there. Okay. These are my office hours. You know, they're right after the end of our lab session. We have a teaching assistant, Sushmita Atapuram, and she will join us in the lab today. So you can meet her there. This is her email. You'll use that email. When you submit an assignment, you'll send files to her at that email. And when you do that, make sure that you CC me. So whenever you interact with the teaching assistant, I'd like to be involved in the conversation. Just CC me. She'll respond to you directly, and she'll CC me as well, right? There's my email. This is her email. And of course, this is the website. That's where we're at right now. Actually, but the URL looks different. And I think I can fix that, actually. You see this URL? It says CSE on there. It says CSUSB DT. So I'll try this alternative URL. And it's the same thing, but it just has a different location. That's because my website is running somewhere else. And I'm using what's called a proxy on in our department web server. The proxy requests so that they're directed to this other site. So I have two URLs there.
They're the same?
They're the same content, yeah. I just need to fix my, bookmark here. There we go. Never go there again. So we cover the first 6 chapters of the book. And the material that's presented in the book. Oh, 3 exams. This is not correct. There's 2 exams and a final. So in the past, I used 3 exams and a final, but I'm going to compress exams 2 and 3 together, the old version of 2 and 3, and just have a second exam. So there's assignments and these exams, and there's deadlines, and there's coming to lab and collaborating with other students, and I guess you can think of the class as a problem-centered class. You don't have to write essays. I'm not going to ask you any multiple choice questions. You won't get a bubble form to fill out on the exams. You have to solve programming problems. That's what it is. You'll be given problems to solve, and you'll have to solve programming problems. So on the exams, either you write code, a small amount of code, or you read a small amount of code, and you analyze what it does, and you say, oh, this little piece of code prints the number 3, and that's your answer on the exam. Or how do you compute the sum of the first 1,000 even integers? Show me the code that would compute the sum of the first 1,000 even integers. So you would write down the code that does that. Okay, you would do that on the exam. So that's the nature of the course. The course is problem-centered. So you're given one problem after another. It's like a math class. So you know, when you take a math class, you learn about how to solve problems. All right. So one of the goals of the class is to learn this language called C++. We won't cover the entire language. If you take the subsequent course, 202, then you'll get the rest of the language. We're just getting the first part of the language, but a good amount of the language. You can do a lot with what we're covering, with what we will cover. We'll cover about, a lot. You know, most of what programmers would use, we will cover of this language. Now, covering this language, this is a difficult language, in case you don't know about it. It's used a lot in industry. Like the browser here, this is written in C++. And the operating system is written in C or C++, not sure. And there's a lot of existing code, a lot of existing systems that are built using C++. It was a big language for a long time. It's still very big. But it's a difficult language. And perhaps that's why we only cover some of it in this quarter. But what you learn in this class is applicable to any language that you would study later on. All the other languages, Python, Java, JavaScript, Lua, whatever language you could run into later on, you can fall on what you learned in this class to help you. In many cases, the syntax will be identical. You'll see a lot of similarities between this language, C++, and Java, and C#, and JavaScript, and the list goes on and on. Some languages deviate more, like Python, it's a little bit different. Ruby, it's even more different. But the same basic concepts are there. How to specify a loop, how to define a function, how to define a class, and so on. So there's a lot of common knowledge that you'll be picking up in this class, even though we're focusing on this specific language of C++. These are some of the topics that we learned. I'm not going to go through the list. You can read that. So the lab assignments are due the Friday following the day of the lab. And if you're late, then you'll lose some points. And I don't know if I explained that in here. 75%. If you're within 7 days after the deadline, then you can score a maximum score of 75% on the lab assignment if you're late. All right. And programs submitted with compilation errors receive no credit. How many people know what that means? That's great. Half, maybe almost half the people. So I'm not assuming you understand that line right now. So compilation means you take source code, like your computer program written in source code, and you run it through another program called a compiler. It translates the source code into an executable file. That's called compilation. And so if the source code has a syntax error in it, in other words, if the compiler can't understand what you want it to generate, then you'll get an error. You'll get a compilation error, and it will refuse. It will not generate an executable. That's called a compilation error. Well, let's suppose you do generate an executable. Your program still may be wrong. There may be a bug in the logic. So when you run the program, it crashes, or it doesn't produce the behavior that you need it to produce. That's called a runtime error. There's two kinds of errors: compilation error, It's a syntax error. It's kind of like a grammar mistake in your essay, right, in an English class. And then there's a runtime error. If you don't have any grammar mistakes, the spelling is good, that checks out. But wait a minute, your essay didn't address the question you were supposed to answer, or it has a faulty argument in it, or or the sentences are confusing. It has other weaknesses. That's like a runtime error. When you run the program, it doesn't give you the behavior that you need. So when you're doing the lab assignments, don't bother to submit code that doesn't compile. That won't get any credit at all. Initially, you'll find you might experience it to be difficult to debug the syntax errors and solve compilation errors. But actually, as we go through the quarter, you'll see that that's the easy part. The hard part is the runtime errors. The syntax errors are relatively easy to correct, although you'll have some trouble with it in the beginning. Now, source code it's like that, source code in this class is like that essay in the English class. There's readability issues. It's meant to be read. It's meant to be read, unlike the English essay, the programs you write in this class are meant to be read by the compiler and by people. So you're writing to two different kinds of things, a machine and a human. In English, you just write for the human. So you could write code that the machine understands and runs correctly, but that's not good enough, because most programs are living things. They don't stay still. They're always changing, always. How your system is updating itself all the time? That's the program that's changing. And so most systems are always changing. And in the workplace, when you're assigned to a problem, usually the program you're working on is enormous, thousands of lines of code, usually. And you've got to keep track of thousands of lines of code. You got to know how to navigate through a big, complicated, piece of software. It's like looking on a bookshelf and seeing the U.S. federal tax code. I looked at that once. I went to the library. It's like 5 feet long on a library bookshelf. That was some time ago, by the way, 25 years ago. That's like your program. It's that big. And how do you, and then the client or your customer or whatever, the management says, we got to make a change. Well, you got to know which book, which chapter, which section, which sentence, which word in the sentence. You got to know how to find stuff. That means the code has to be easy to read. It has to be well organized. And so here are some guidelines in the syllabus on how to make your program readable by humans, not by the compiler. I would say that this one, in this class, logical indentation is the most important readability criterion that you can learn in this course. So you've got to get this. You should look at me, how I indent the code when I'm writing. Look in the book that you're using. Look at how it indents the code. The indentation of the code expresses the logical structure of the program. This is very important. If you don't keep your code clean and well organized and readable, then you're going to end up spending a lot more time, because it's hard to comprehend what you're working on. And as the size of your program grows, of course, it gets worse. Anyway, you can read through all of these all of these criteria and try to apply them when you're working in this class. Here's the grading schedule, learning outcomes, and rest of the stuff. Any questions on this overview, the syllabus, and how the course works? Okay.
For
Yeah.
the compiler, does it matter what system you use? Like computer?
No, you can use any C++ compiler. It doesn't matter. When you submit your work, you'll submit source code, a simple source code. Any compiler is going to be able to handle it. So you can use, if you're on a Mac, I recommend Xcode. It's free. Go to the App Store, look up Xcode, and install it. It's free. And on Windows, you can install Visual Studio. It's a little harder to work from because in the Mac, you've got an interface with this nice console window. It's like Linux. You know, our labs, we're running Linux in labs. It's a Unix, Mac is, OS 10 is a Unix style operating system. So that's why a lot of programmers are using Macs these days, because the interface resembles the kind of machines that you would use, say, in a data center. You know, servers. You know, maybe you're managing 100 servers or 50 servers, database servers, web servers, transaction servers, all kinds of stuff. Those are generally Unix-based operating systems. They could be Windows as well, but normally they're Linux actually. Normally. And, but there's a lot of Windows systems too on the server side. But, you know, the big companies are not running Windows. Yeah. Facebook is not running Windows servers. Google doesn't run Windows servers. Does Microsoft run Windows servers? Maybe. They would be the only company I could think of. Maybe some others. Maybe ESRI runs some Windows servers for some reasons. But that would be smaller. You know, smaller number of users that would be hitting them. All right, so anyway, that's the platform. So you can use any compiler, and on it, if you're running Linux or you have, you know, running Linux in a virtual, running it as a virtual machine, that's probably the easiest way to go. Visual Studio, you have to do some extra work learning how the interface works, the Visual Studio interface, and I can help you with that. So if you have a laptop and you have Visual Studio installed on it, you can bring it to me and I can help get you started. There's a few little things I need to point out to you to make it work well. But on the Mac, you'll watch, I'll be working on the Mac, and that's easy. Oh, there's another environment. There's another environment that you can work in, which I'm going to try for the first time. And it's called, you know, it's a web-based IDE. And there's several of them out there, these companies. But the company that I'm going to use in this class is called Cloud9. Now here's the first lab. Let's take a look at that. This is the lab's, the command line. This is the command line right here. So I type in something, current working directory. That's the command line. ls, list the contents of the current directory. mkdir, make directory 201. List the contents of the current directory. Oh, look, there's the 201. I just made it. See, I'm working at the command line. This is what I mean by the command line. This is the terminal window. I'm going to change directory to 201. You see my prompt changed. I just had tilde, and now it says 201. And I configured my system so that the prompt would show the name of the current folder I was in. I made that configuration. Yeah.
Are you going to use Codecademy except for the command line? Is that the only reason we're using Codecademy?
Codecademy?
For the lab to turn in to complete your
Oh yeah, Codecademy you just use once for the lab. So what I'm doing here, this, change directory, that sort of thing, print working directory, you see this? This is the path in the file system of the current folder that I'm in. So there's this idea of a current folder, current working directory. You've got a file system, it's a hierarchy, a tree. There's one root folder, and then you have subfolders, and subfolders within subfolders, files within those folders. Folders contain other folders, and they also contain files. So you can think of it as a tree with the root node at the top. And when I do PWD, print working directory, it shows the path through the tree from the root to my current folder. The current folder is 201. We created that folder up here. Where did I create it? Right there. I used the mkdir make directory. I used that command to make a folder named 201. And it made it where my current folder currently was. When I issued the command, I was in this directory here. And I'm going to change that. Actually, I just had the system administrator reinstall the system for me, and she used that name there. So I'm going to, next time you see me, maybe I'll just say Turner. Is that David Turner? All right, so this is the lab. This is the first lab. And you have a number of ways to do these labs, to do the programming problems. You can work on a lab machine. During the lab hours, you can work on a lab machine outside of the lab hours. And the machines in JB 358 and 359 are identical, so you can work in either room. So if one room is being used by a class, you can go into the other room. So that's one way to do it. Another way to do it is to work remotely. You could be at home and you can log into some machine in one of these rooms. Okay, so you use a program called SSH, or you can use another technique, which is this SSH X11 forwarding. That's where you get a GUI interface. It's more, consumes more bandwidth. Might be slow. I never used it. So you could be working at home and connecting to a lab machine and working on a lab machine remotely. So that's the second option. Third option, you can work in a Cloud9 workspace. And this is the first time, I'll try this for the first time this quarter. I think this is maybe the best option, but maybe it's going to be too slow to use. I'm not sure yet. We'll see how it goes. Or in OS 10, like I'm in here, you can work in a console window like this. So you write programs, you run a compiler like this. No file called PPPP. Right? So that's running the compiler at the command line there. I'm in OS 10. Now, that compiler that I just ran in Mac is an Xcode compiler. But I didn't start the Xcode IDE. I didn't start the Xcode graphical user interface. It's too much. The programs we're writing in this class are small, simple programs. So we can do everything from the command line in terms of building. If you want to learn Xcode, that's great, but it's big, it's huge and complicated, just like Visual Studio. So if you do it the way I'm doing it, it's the same way that you would run programs in the lab. So what you see me do in the Mac is what you would do in the lab, essentially. And Linux, you can have a Linux machine, Linux on your laptop, or Linux running as a virtual machine on your laptop. And it'll look just like what I do in class here in lecture. If you have a Windows computer, well, you can always connect remotely using one of these techniques, or you could use a Cloud9 workspace, or you could install Visual Studio and use that to write your code in. A Visual Studio is good to learn. If you're going to be a programmer, you should learn this. If you have a Mac, then you learn Xcode. If you have Windows, you should learn Visual Studio. You can get a free version of this from, I think they call it DreamSpark, or you can just look it up. It's the, what do they call it again? There's a professional version of Visual Studio, and then there's a
Chris.
Express version. Thank you. Get the Visual Studio Express. And when you get it, the last time I looked, there were 3 options. You can get it for web development, for desktop development, or for some other thing. Oh, like the
Yeah.
tablet development, right?
I think there was an application.
Huh?
There was like an application.
Yeah, I think it's for their tablet, Windows. What's that? The operating system for the mobile Windows mobile phone. What's it called? Does anybody have a phone running Windows on that? 5 years ago, I met some business people. They had phones with Windows. And young people don't do that. It's either Google, it's either Android or iOS. Right? But Windows has a operating system for the phone and tablets. And I think the third option is for building for that environment. But you want the one where you're targeting the desktop. So we're running things on a desktop. And I want to show this to you briefly here. Cloud9, this is what I'm tempted to say I recommend this. Oh, what's going on? Cloud9 workspace. That is not right. I got to fix that link. So here's my workspace. My workspaces, right? And to work in this class, let me show this to you. In this lab, you're going to compile this program. This program is the hello program. It just prints hello at the terminal window. Let me show you how to do it in terminal window here. So I've got a text editor called VI. That's what I use. You don't have to use that. You can use whatever you want. And here's the code from the web page. You know, it's got lines. This is a statement to the compiler reads this thing. This is not an executable. This file is not executable. I can't double click the file and have it run. It has to be translated into an executable. So this is called source code. And the source code is read by the compiler. The compiler will generate the executable from it. So this is information that's given to the compiler. It says include this header, the IO stream header. It means expose a whole set of functionality to me that I'm going to use. So there's this additional functionality that's part of the C++ language, but it's not available to you by default. You have to tell the compiler that you want to enable it. You want to unlock that set of additional functionality. Now there's lots of these. IOStream is just one. There's a lot of these header files to unlock or enable different groups of functionality. So IOStream, this is for input-output. I is input, O is output, input-output stream. So they use the word stream there because you think of it as a stream of data. There's this output stream, and you just send bytes of data into it like a stream. Or you've got information coming into the program, it's coming in as a stream. You're reading it as a stream of bytes. And then here's another line that says something. It says, oh, let's assume that all the names that are in the STD namespace are visible without qualification. in the code that follows. And I'll talk more about that later, okay? Then this is called a main function. Here's the word main. It's the name of the entry point for the program. This is where execution starts. This is just some preliminary stuff to tell a compiler what to do, set up the context in which to understand the code that follows. But a main is a function, and this is called the entry point. It's where execution starts. Now, the program only does one thing. It does this one line here, and that line prints the word hello in the console window, right, without going into the details. And all this business here, this stuff here, this argument list, that's for reading things from the command line. When you run the command at the command line, you'll type in the name of the executable, but then you can follow the name by some other stuff. That's information passing into the program. And the program accesses that extra stuff with this char pointer array right there. And this argc, that's a number of extra stuff that's in the array. This is the array. Now arrays we're going to cover at the end of the quarter, right? Or near the end of the quarter. I'm talking about something that we won't use for another 6 weeks. We're not going to use this until 5 or 6 weeks later. Yeah.
Were you talking about so we can read this easier for the whoever's reading the program or reading your lines? Are you talking about defining your parameters, like / defining exactly what the parameters are? Are you talking about the algorithm? Why?
Like this here.
Yeah.
This, you know, this thing is called this is the parameter list, and that is in a later chapter on functions. I'm kind of hazing over everything right now, and we will look at this in detail when we get there. Okay, but you're right. These are parameters that are specified for this function. But you don't have to understand this right now. We're going to get there. But I want to give you a shell to start working in. Okay, so this stuff here you might not understand. This you might not understand. This you might not understand, you know, but I'm going to help you get that. This you have, the way I explained it now, you're enabling a set of additional functionality. That's reasonable to say, yeah, okay, that's what that means. And so this is, all of your code is going to be in between this opening brace and this closing brace. And this is the place that you need to focus on understanding. It's that line right there. That's where we start. How are we printing the word hello? Well, you know, this is called an operator. You know, it could look something like this. Let's see. Like if I did, you know, 1 plus 2. See that? This plus sign is an operator. And it's a binary operator. It takes 2 arguments. There's a left-hand side, which I have as 1 right now, and a right-hand side, which I have as 2. That's an expression. 1 plus 2. It's an expression that's built around this plus operator. This is an expression, and there's an operator here. It's the output operator right there. There's 2 of these together, not a single one. This single operator is these 2 characters together. That's like the plus sign. See, and there's a left-hand side and a right-hand side. The left-hand side is cout, and that's a predefined name, which is actually defined in this IO stream. And or it's declared in IO stream. So if I omit this line here, the compiler's going to say, I don't know what cout is. When I put the line in there, the compiler's not going to complain because now it knows what cout is. Because these header files, they enable functionality, and that means that they give meaning to names. Not all names, but certain names. And this particular header, IO stream, gives meaning about the name cout as well as other names. And cout represents the output stream, out for output stream. It's a standard output stream. I don't know what the C is for. Maybe character output. Did I get it? And so we have the standard output stream. So when we write into the standard output stream, what we write into it gets displayed in the console window, because when we run the program, if we don't change anything, the default environment, the default configuration is for the console to be the standard output device. We change the standard output. When we run the program, we say, we don't want the console to be considered standard output anymore. We want this file over here to be standard output. So now when we run the program, we're streaming character data into the file, not to the console anymore. So we use this name standard output to give some flexibility in how we execute the program. But you can think of this as representing the display of the terminal window, standard output. And that's the left-hand side. That's the destination, where the characters are going to go. And the right-hand side is what to send. And here we want to send a string of characters. Now the quotes here demarcate the string. They say where the string starts, where the string ends. The string is a sequence of characters. The quotes, the first quote the compiler gets to, it says, oh, you're starting a sequence of characters. You're starting a string. Okay. Then the compiler says H, okay, you're the first thing I'm going to send to the output. E, you're the second thing I'm going to send to the output. L, L, O, and then /n. That's a special character. It's actually two characters together, but the compiler interprets it as a single character. So slash is called an escape character. It's called an escape sequence, \n. So it means I want a new line. You know, when you're typing and you hit the return key like that, and when you see like a word processing document, you see a line and then you hit enter and then you write the next line. Well, there's an invisible character there. There's an invisible new line character there. And because we can't see this invisible new line character and we can't type it in, we can't represent it. Like if I wanted to put a new line inside the string, if I hit enter, I break the code, right? So we can't do it like that. So we have to use a special sequence called an escape sequence. It starts with \, and n represents, they use n because it's the first letter in new line. So it's a new line character. So this is a new line character. So that's one character. Even though we see two characters there, the compiler sends one character to the output stream. And then the compiler gets to hear the second quote, and it says, oh, that's the end of the string. That's all I'm going to send. And then the semicolon is used to tell the compiler that this is the end of the statement. This is your operation is, we finished defining the operation here. So that's where your attention should be right now, is understanding this expression here. And then you can change this. Oops. Instead of printing hello, let's print bye. There you go. Now you're changing the code. Now I'll quit this editor here. ls, I'm going to list the contents of my current folder, main.cpp. That's the file I just created. Now let's compile it. It says nothing. That's good. If it said something, it says something if there's an error. I'm going to do ls again. I'm going to see what's in the folder. And I said the compiler reads source code and generates an executable. So we should see the executable file in the folder. Do you see it? What's the name of it? A.out. That's a default name. Now, if I want to change the name, I can use -o, hi.exe, say, right? Now, it generated hi.exe. Well, you wouldn't use exe on a Mac, but you'd use exe on Windows. And if you don't specify, in this here, I want to slow up for a minute. This is called a command line. This is a command I'm entering on the command line. The console window is a command processing tool. It's a way to communicate with the operating system. You type in a line, call it a command, you hit enter. Enter submits the command to the operating system, or the terminal program actually. The terminal program carries out, the command. It executes the command. And this command says, I want to run a program named C++. That program happens to be the compiler, C++ compiler. And then I got to pass in some information to the running program. I got to tell it here this is called the first argument. These are called arguments to the command. The first argument is the name of the source code to read. The second argument is this option to what to name the file, the executable file that gets generated. And this is optional. So I can omit this. And then it's going to generate the default name of a.out. Of course, if I omit this, it's going to say, well, no input files. It doesn't assume main.cpp as the default source code file. So we got to tell it, we have to give at least that as minimum information. Now, I'm going to do rm for remove hi.exe. See that? That's how to delete a file. On Windows, you use del. But on Unix systems like Linux and Mac OS 10, you use rm for remove. And now it's gone. But a.out is there. How do we run a.out? If I do a.out, it won't work. And I want to execute. See, if I run C++, it finds the command. Because I'm going to use this which command. It shows me the path to the C++ executable. That's the location of the executable, the compiler, in the file system. But a.out doesn't have a location. Well, we know the file is there. We can see the a.out is there. How come it doesn't find it? That's because the command line interpreter searches a path. When you enter in a command, it searches what's called a system path. And it's just a list of folders to look in to find the command. So this folder here, usr/bin, that is in the path. That's in the system path. So the command line interpreter, the console window, will look there and say, oh yes, there's a file in there called C++. And that must be the executable that the user wants to run here. And so it found the executable, it can run it. But a.out is in the current working directory, which is here. That current working directory is not in the system path. So the console window won't find it. So we have to give it its full sort of position in the file system. See, that's the fully qualified file name. It's the path all the way to all the names of the folders, one after another, separated by slashes. You separate the folder names with slashes. Now when I run this, there it says by, right? We changed it to say by. there's another way to do this. You know, if I do print working directory, this shows me my current working directory right there. So this a dot out is right inside the current working directory. So is there a shortcut to say current folder? There is a shortcut, and it's a dot. That means current folder. So I do dot, and then you have to separate the folder name from the name of the file. So it's dot for the current folder slash, that's the end of the folder name, a dot out. Now it runs, there we go. Now there's another way to run it. There's many ways to run this. You see here, print working directory, this is where we are right there. But my home directory, I have something called a home directory. And the home directory is here. That's my home directory. User is David Turner. And I think I can also do this. I think there's an environmental variable named home. I dereference that with a $sign. Yeah, it's the same thing. See that? They're identical. There's all kinds of ways to find things and to things that you need to learn. All of this works on Windows too. You know, they don't use PWD. They use something else. I forget what they use. Oh no, they do use PWD on Windows, I think. And I think home is defined on Windows, but instead of ls on Windows, they use dir, and then they would use these % signs like this, something like that would be with Windows equivalent. But usually don't work in the command line of Windows. It's very discouraged by Microsoft. But sometimes you have to, so you got to know this stuff. But for OS 10 and Linux and other Unix systems, the terminal window, the command line is very important and heavily used.
So in the command line right now, are you logged into your account? Is there a way to log out of the console so someone can't just access the console?
Yeah, well, you know, I'm running, you know, the graphical mode of this interface here. So I'm in OS 10. So yeah. Yeah, I can't log out from the terminal window here.
Okay.
Because someone can just execute, you know, using the graphical user interface. I'd have to log out. I'd have to go here and right there. I'd have to log out there.
Graphical way.
But if you're logged in remotely, then you want to log out, you know, from a remote machine. All right, let me see here. What am I getting at? Oh yeah, so I can also, one more way I'm going to show you, tilde, you know how dot is a symbol that represents the current folder. But tilde is a symbol that represents the home folder. So under the home folder is a 201 folder, and in that folder there's an a.out file. So that's another way to specify the path to a.out that we generated. You see the flexibility there. Lots of ways to do this. And look what happens when they go to the home folder. By the way, CD with no argument, we change to the home folder. And instead of displaying David Turner, the system, the console displays tilde. See, that's the symbol that represents the home folder. And another symbol that you want to, there's three symbols. There's dot, there's tilde, and then there is dot dot. What does dot dot represent? Dot represents the current folder. Dot dot represents
Go back one.
the parent folder, the folder that contains my current folder. It's kind of a backwards operation, yeah. Now, here I'm working in in the OS 10 terminal program. In the lab, you can work on the terminal window up there. If you're running Linux on a laptop, you can work at the terminal window there. You can use SSH to work on the terminal window in the lab. But the new option that I'm going to talk about and demonstrate and encourage is to use the, not the tutorial, the this Cloud9 workspaces. So this is where we're running our execution environment will be on a remote server. So let's go ahead and create a workspace. How do I do that? Does that mean create?
I think it's the
Yeah, create a new workspace. Here we go. And workspace name, I'm going to call it CSE 201. I'd like to call it just 201, but I tried that and it rejects that. And, you know, you have to pay to make it private, so we're going to keep it public. And then they have these templates, and all of these are nice. They have all different kinds of development environments in there. You're tempted to click on this C++, but that's going to give you a makefile and be confusing. I'm not going to cover makefile, so I think you should just use something like custom, maybe that one. Custom, a basic installation. There we go. So this will be simple. So now it's like starting up some on a remote server. It's initializing the environment to use and creating it. I don't know if it's a virtual machine or something else. I think it might be something else. I think a virtual machine is too expensive. So here's the command line. It's a Linux system. So you see PWD works. Then we have a workspace here. Ubuntu, by the way, that's the name of a Linux distribution, a distribution of Linux. And here's ls. There's a README in there. They've got VI, just like, and like I'm going to expand this. Make it easier. It's hard to read this, isn't it? How's that? Is that better? All right, so let's create this file, main.cpp with VI. But VI is messy, I got to tell you. Oops, what did I do? Went the wrong way. What did I do? How do I go to my, there it is. You can use Nano. Nano is easier. But I'm going to use VI in this class. It's a very old tool. It's present on every Linux, Unix system. I know if I log into a Unix system somewhere, I can use VI. It's like this, you know, Cloud9, if you have VI built in. They also have Nano built in. So, you know, you would write things here, and then, what is it, Control W? Oh, write out. So Control O to write out. Name of the file, hit enter. And Control X to exit. And there's the main.cpp. Now we can run the compiler. Oh, like, see, the tab key doesn't work. There we go. Yeah, see, we got to give up stuff here. Command completion doesn't work in this terminal window. So probably I won't use this in the lecture, but you might like to use this on your laptop. So it's saying the compiler, this is called a compilation error. It says, yeah, I don't know what that is. It's saying, I don't know what that name is. So this is called a compilation error. So let's fix that. And let me see here. Here's the hello program. I'm going to save that. Oh, command history is good. Command completion doesn't work, so when I hit tab, I don't get command completion, but the up arrow and down arrow lets me scroll through the history of commands that I issued. So that's very good. So I'm going to rerun this command, and that worked. And look, it generated a dot out with a star next to it. I don't know if that's part of the, no, it's not. The star must mean, I don't know what that means. I've never seen that before. Maybe it means it's an executable, I don't know. So now here we're working in our browser. So you could be on any machine. You could be working on your iPad, right? You can work on your phone right now. You can do your lab exercise on your phone right now with this interface. Well, actually, I haven't tried it. Maybe this doesn't work well on the phone. But you can try it. So this is convenient. And then to submit your work, before you submit your work, you have to share your workspace with me and Sushmita, the lab, the teaching assistant. So there's a function to share the workspace. Where is it? It's in here somewhere. Maybe it's, how do I get back to, I close that other window. So it's c9, cloud9.io. I think if I select this like that, where's share? It's shared with me, the people. So I'm going to see everybody in there. Everyone who uses this, you're going to share your workspace with me. I'll be able to take a look at it, right? See, so I've got some people that are sharing stuff with me already. But if I want to, if I'm you now and you need to share, I think what I do is I select this here without going in, and this little gear. No, that's not how to do it. How do I share this? Does anyone see how to share this? Anyway, I'm not sure how to do it. What's that? That one right there? No. They're going to sell you stuff here, okay? They're going to try to sell you stuff. All right. There's got to be a way to do this. Hold on. So this is, let's suppose this is this workspace, and I want to, so you have to figure it out. There's a way to do it. As you can see, I showed you a list of students that are already sharing workspaces with me. Now, if you're using Cloud9, first to share your workspace, you only have to do it once for the whole quarter with me and Sushmita. And then you send an email to Sushmita, CC me, and say, I finished lab 1. You know, here's my, that's it. You don't have to send any source files. Oh, and also send the link to your, system. So like this, you would copy that and send that. Instead of sending the source file, send this link. Every time you send an email, send the link. Because we're not going to be able to remember. I'm going to have this huge list of students with all their workspaces. I can't, you know, I want to see the link in my email. I can click on the link and go directly there, okay? So send that link. And that's how, now if you're not using Cloud9, you're using one of the other environments, you have to send, when you send an email, you have to attach source code files. Don't attach any executables. We don't need a.out. We don't need, you know, a.exe on Windows, whatever it is. Just send the source code. One last, wait a minute, let me just wrap it up here. This lab here is to learn about the command line. how to use the file system, what the file system is, what are the commands you need to learn. Get comfortable. I have a long list of different development environments you can work in. And you can work in multiple environments. You don't have to just pick one. And then there's this tutorial here, Codecademy. There's a command line tutorial. I've never used this before, but I've used Codecademy in my other classes. It's very good. It's free. It's excellent. All the students that I've talked with and used this with in the past have all given this very high marks. So this is going. I'm sure that this is going to work out nice. I went through this tutorial. It's pretty good. You need to go through this tutorial, and then you need to compile this thing, this program, modify it, and then submit your work. That's basically what you do for Lab 1. And the deadline for that is Friday. Right? Okay. Any questions?
Does it matter our username for the Cloud9 program?
No, any username is okay. Any other questions? Yeah.
This is Friday and the labs are Monday and Wednesday. Does that mean that Wednesday people might be suggesting to start early?
So the labs are Monday and Wednesday, but at some point the Friday's going to come in the middle, right? Is that what your question is about?
Like Wednesday doesn't have as
No,
much.
the same deadline for both labs. Let me tell you what happens normally. You're going to discover that you don't need to go to the lab anymore. And you can work at home, right? And some people will come to the lab because they work better in the lab, because I am in the lab. So Shmita is in the lab. We're helping in the lab. And you can sit with your collaborators in the lab and help each other. So the lab is a good place to go. Well, you don't have to be in the lab. You can work at home. So a lot of the students end up working at home. And then if you're assigned to Lab A, well, you can come to either lab session. In the first week, stick to the session that you're assigned to. So everybody's going to go to lab together, and all the seats are going to be filled. But in the second and third weeks, third week at the latest, there'll be a lot of extra seats in both lab sessions. So you're going to go to both lab sessions. So you're going to have the same deadline for everybody. It doesn't matter which lab you're assigned to. Okay? Does that answer the question? Yeah. And you'll see, I'm going to post this lecture on YouTube. So you see all the people in the room right now? They're going to see a lot less, next week. You're going to say, I'm just going to stay home and watch the YouTube. And then I'm going to use Cloud9 and then send an email. And then, but still, it's useful to come here because you can interact with me, and it just feels different, right? It's better to get away from home. Maybe you can shift your attention a little bit better and focus on the material better. So whatever suits you. It's very flexible, this environment. Yeah.
What do we have to search for on YouTube to find it?
No, I will give the link. On this, you see this lecture date right here? I'll turn that into a link, and a link to the video.
Okay, cool.
That's it. See you later.